All right, sorry about yesterday, guys. Can you guys hear me? I want to make sure first because I had issues the other day. We good?
Yes, sir.
Thank you. All right, so we're going to start here on day 2 of doing the area using the LRAM and the RRAM. We're going to actually get into some of the examples and how this all works. Okay. All right, so we're on example 2 here. And the directions say using n subintervals, find the upper and lower sums, RRAM and LRAM, that approximate the area of the region bounded by the graph of the function and the x-axis over the indicated interval. Show your calculations. Okay, so before we actually get into this calculus way, I wanted to show you guys this. I actually sketched this graph, the graph of 9 minus x, which is this line right here. Okay, and we want to find the area bounded by the graph, okay, the x-axis, and then these boundaries. Okay, so we're going from 2 to 8, which is this right here. Okay, if you don't remember, okay, this is a nice pretty trapezoid. Okay, it's not your traditional trapezoid where your bases are up here and down here, but it's a trapezoid nonetheless, looking like that. Okay, not a triangle. Don't fall for the little piece right there that makes it not a triangle. Okay, but we do have a trapezoid. Okay, and if you recall, the formula for the area of a trapezoid is 1/2 times the height times the sum of the bases. So I actually found the area of this shape using traditional geometry techniques, okay, and a geometry formula. Okay, which obviously is not going to be the case for most of our problems today, but the very first one we do, I want to show you that the area is 24. Okay, so this is our problem. Okay, now what we're going to do is we're going to do this using LRAM and RRAM. The first thing you want to do is you want to take the length of your interval. Okay, the length of my interval is 6 units from 2 to 8. So the length of my interval divided by the number of subintervals, which is going to be 1 in this case. Okay, and what I do until I get really good at this is I put on here, I'm going from 2 to 8 by 1. So I just draw myself a number line 2 to 8 by 1. So I'm going to have 3, 4, 5, 6, and 7, and then obviously 8. Okay, what this is doing, even though this is not really the graph of it, is these are my rectangles. Okay, I should have this many rectangles. Okay, that's going to be 1 rectangle, 2 rectangles, 3 rectangles, 4 rectangles, 5 rectangles, 6 rectangles. Okay. All right, from there, we're using LRAM. Okay, the base or the width of every rectangle is 1. Okay, so we're going to write area equals 1 times. Okay, and when we're using LRAM, we're going to start with our very left number. Okay, that's an x value, and we want to find f of that x value. Okay, so we're going to multiply the base here times f of 2. Okay, so what we're really doing is, if you go back to my rectangle, or I mean to my actual trapezoid here, is my very first rectangle is going to be that rectangle right there. Okay, that's my first rectangle. My second rectangle is going to be this one. Okay, then my third one, and so on as I'm drawing all my triangles. Now, obviously, with this diagram, you can see this is going to be an overestimate. We'll talk about that in a little bit. But the base of every one of these rectangles is 1. The height obviously changes. The height of this one is 7 because f of 2 is going to give me 7, right? 9 minus 2 is 7. This step that I'm writing out right here, eventually you don't have to do or necessarily have to do. And you could just go right into writing 1 times 7 plus 1 times and keep going. But I'm just going to write it out for you. So plus 1 times f of 3 plus 1 times f of 4. And I stop after I do 6 numbers, right? Because I want 6 rectangles. Okay. Now you'll notice on your number line, that means you're going to go from 2 all the way to 7. Okay. So plus 1 times f of 5 plus 1 times f of 6 plus 1 times f of 7. Okay, that's my left y values. Okay, obviously not 2, 3, 4, but my left y values. This y value is this one. And then when I get this y value, and then when I get this y value, and so on, these are right here and as we're going. All right, so we actually go find this. F of 2 is 7. F of 3 is 6. F of 4 is 5. F of 5 is 4. F of 6 is 3. And F of 7 is 2. And if we add this all up, we get a total value of 27, which, based on us seeing this diagram right here, we knew we were going to be an overestimate. Okay, so on this particular one, we actually know that the exact area is 24. LRAM gave us an overestimate because it was giving us all this extra area outside of our graph. Okay, and as we keep going, we keep getting that extra area in all these. That's the last one. Okay. All right, so now when I'm doing RRAM, okay, the base or width of my rectangle is still the same, okay, but now my y values are different. So I'm not going to start at 2. I'm going to start at 3 because I still want 6 numbers. And when I'm doing RRAM, in theory, okay, I'm really starting from 8 and I'm working my way back, but I like to write them in order. And certainly if you want to write f of 8, f of 7, f of 6, f of 5, f of 4, f of 3, you could do it that way. But you're still going to get 6 values because there are 6 rectangles, okay? So we're going from 8 to 3 this time. So it's 1 times f of 3 plus 1 times f of 4 plus 1 times f of 5 plus 1 times f of 6, 1 times f of 7, and 1 times f of 8. Okay, and again, you should have 6 values there. Okay, 1, 2, 3, 4, 5, 6. Okay. And nothing's really changed. Well, a little bit has changed, right? We're not going to have this 7 anymore, but we're going to add another number on this side. Okay, so f of 3 was 6 plus 5 plus 4 plus 3 plus 2, and f of 8 is 1. And that all adds up to be 21. Okay, so my upper limit, which in this case was an LRAM, was 27, and my lower limit or lower area was a 21 from using RRAM, and that's an underestimate. And guess what happens when you add these two numbers up and divide by 2? You get 24, which is the exact area. Okay, again, that exact area thing is only going to apply if it's a shape that we already know the area to. Okay, if we have a formula that, it's not going to apply to something that is curved, which is obviously the next one we're going to do. Okay, which is x squared. Okay, do I have any questions on how I came up with all this algebra in here? All right, so I'm just going to do a quick sketch of x squared, but if I have the graph of x squared, okay, and I'm going from 1 to 9, so I'm just going to kind of, don't go based on this scale, but let's just say we're going from 1 to 9. I want to know the area of all this right here. Okay, now we're curving, so there's no geometric formula that's going to help us with that. Okay, and so that's obviously where LRAM and RRAM come in. Okay, so our function is x squared. The first thing I'm going to do is I'm going to say my interval is from 1 to 9, which is 8 units long. And we want 4 subintervals. That's 4 rectangles. Okay, remember we talked about on Tuesday, the more rectangles you have, the closer to the exact area you're going to get. Okay, so now we're only doing 4. We did 6 in the one above, right? Okay, so 8 divided by 4 is 2. I'm going to draw my number line and go from 1 to 9. by 2s. So the next number is going to be 3, the next number 5, and the next number 7. And sure enough, you're going to have 1, 2, 3, 4 rectangles in there. And that's exactly what we want, is 4 rectangles. All right, so doing an LRAM, okay, up here, this number was a 1 every time, okay? It's now going to be a 2. If this number is the same every single time, and that will change, okay? Instead of writing 1 times plus 1 times plus 1 times, or in this case, 2 times plus 2 times, we can write the 2 out here and then just find our 4 y values, which is the height of our rectangles. Okay, so doing an LRAM, we're going to do f of 1 plus f of 3 plus f of 5 plus f of 7, okay? 4 rectangles using our left y value, LRAM, left rectangular approximation. Remember, x squared is going to look something like that, right? Okay, so these rectangles are all going to have different y values, right? Okay, so this first rectangle, since we're doing LRAM, is going to be that one, then that one, then that one, and then that one. Y value of when x is 1, y value when x is 3, y value when x is 5, and y value when x is 7, LRAM. All right, now I would just plug into my function, obviously. So 1 squared is 1, 3 squared is 9, 5 squared is 25, and 7 squared is 49. All right, let's add that up. We got 40, 69, 74, 75, 84. And then 84 times 2 is going to be 168. So we're approximating the area to be 168. Now, because I drew this curve and the graph here, right? And we know that we're doing an LRAM, we know that this is an underestimation. Even though it didn't really ask us and we haven't talked about that much, but this is an under. And obviously when you do, if you're doing both LRAM and RRAM, then it's going to be obvious which one's over, which one's under, and you don't have to really think about drawing a picture and figuring it out. But if you're only doing one of them in AS, then obviously you have to figure it out. All right, now for RRAM, the base is still 2, but now we're starting on the right and we're doing 9, 7, 5, and 3. So we're doing f of 3 plus f of 5 plus f of 7 plus f of 9. Okay, and I'm going to just, after you write that down, I'm going to draw this picture going this way this time. Try and do it in red, and hopefully you can see that. Okay, so here's my graph of x squared, and I'm starting with an RRAM, right? So where this meets, okay, I'm drawing my rectangles this way this time, okay? And obviously you can tell by the picture, we're an overestimate this time, and I want these 4 y values instead of those 4 y values. All right, like I said, the first 3 are going to stay the same because you did them up here, right? So we have 9 plus 25 plus 49, and then f of 9 is 81. We add that all up, we divide by 2, and we get 328. Okay, obviously a big difference that time, right? The example we did yesterday.
Could you move your paper up, please?
Yeah, I'm sorry. The example we did yesterday that I just showed you and we just kind of walked through. I think we had, I can't even remember, like 5.3 and 4 and 3.3 maybe as our areas. You know, not a big gap there. Okay, the one we did today, the upper area was 27, the lower area was 21. Not a big gap. Okay, in this one, because our graph is getting bigger and bigger, and the interval was bigger. Obviously, there's a big gap between these two answers. Okay. And the area is somewhere close to the middle of that, not the exact area, but it is somewhere close to the middle of that. All right, do I have any questions so far? All right, so we're gonna just kind of go through these this next page or two. I think it's like maybe it's just, yeah, it's actually page and a half of just a whole bunch of calculus speak. Okay, so let's go back to our topic of getting a better approximation. Okay, we understand that if the number of rectangles increased, the difference between the RRAM and the LRAM gets smaller. We changed that last problem to go to 8 rectangles and then 16 rectangles and so on. The more and more we do, the closer and closer that number of 168 and 328 get, that gap closes. Okay. And so we talked about the getting approaching to infinity and all that stuff yesterday on Tuesday. Okay, so really all of this is like a derivative, and not the derivative in the sense of what we've been doing, but this is deriving the formula that we're eventually going to use to find the area under a curve. Okay, and a curve doesn't necessarily mean curvy. It could be under a line like we did in example 2. Okay, I'm not going to go through all this. There's a lot of different notation and, x sub 1s and x sub 2s. So we're going to jump right to this formula right here. Okay, and this is our formula. So what was developed over time is this integral symbol. And I'm going to tell you where that integral symbol comes from. It actually talks about it right here. Okay, the integral symbol is an elongated S and stands for sum, which is exactly what, if you remember back in pre-calc, you guys use this a little bit. I'm guessing, right? In sequences and series, they talk about this means a sum, and you have a lower limit, and then the number up here would be your upper limit. Okay, and then you find the sum by plugging in each number into that function. Okay, that's basically what we're going to do right here. Okay, and then obviously f of x is your function, and then dy dx, the dx comes from the delta x, which is the change in x. All right, although we use the area under a curve as the motivation for explaining this definition, the definite integral is not defined to be the area under a curve, but simply the limit of the sum. Okay. All right, so now here's what the notation looks like. Here is my lower limit, and here is my upper limit. In the previous problem, we were writing it like this. Okay, that was my interval, and then this is my number of subintervals. Okay, but either way, the length of my interval is 2. I want 4 rectangles, so the base of every rectangle is going to be 1/2. Okay, my function is 1 over x. Okay, so again, I start at 1, I end at 3, and I want to go by halves. Okay, so adding a half to this is going to give me 3 halves. Okay, adding a half to that is going to give me 2. Adding a half to that is going to give me 5 halves. Hopefully none of you are thinking 1.5 and 2.5, because we probably want to stick with fractions, especially with the function we have. Okay, so here are my 4 values for RRAM, or excuse me, for LRAM. And then my 4 values for RRAM would be RRAM, 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 and RRAM. Okay, you don't have to write this down. That's just my little notes to you guys, but understand what's going on. Right, we use the 4 left numbers, and here we use the 4 right numbers. All right, so we're going to go here now. Remember, our base is 1/2. Okay, now instead of writing it as area equals, we're going to write it like this. Okay, the integral from 1 to 3, 1 over x dx is equal to, all right, the base of our rectangles is 1/2. and we'll write this one out again. So it's going to be f of 1 plus f of 3/2 plus f of 2 plus f of 5/2. Okay, 4 numbers that we need the y values for. All right, so the algebra obviously gets a little trickier. Okay, remember my function is 1 over x. So I'm going to plug a 1 into that. 1 over 1 is 1. I'm going to plug a 3/2 into that. 1 over 3/2 is 2/3. I'm going to plug a 2 in and get 1/2. And I'm going to plug a 5/2 in, and 1 over 5/2 is 2/5. Okay, you need to be able to know how to do this without a calculator. Okay, your common denominator in this case would be 30. So you get your common denominator of 30, and you end up with 1/2 times, I'm not going to do the basic algebra today, but you get this. And so you end up with 77 over 60 as your final answer. If you were using a calculator, it would be approximately 1.283. All right, so now we're going to do any questions on the LRAM and any values we got? All right, so now we're going to do an RRAM. Okay, the integral from 1 to 3, 1 over x dx is equal to, the base is still 1/2. And now we're using 3/2, 2, 5/2, and 3. So f of 3/2, and this is going to be the last one we write out this step. We're just going to start finding our values. F of 2, f of 5/2, and find the f of 3. All right, so our actual values, we already know f of 3/2 was 2/3. We know f of 2 was 1/2. We now know f of 5/2 was 2/5. And now find the f of 3 is 1/3. And again, I'm not going to do that algebra for you, but it's that. And it actually was a terminating decimal, 0.95. If I averaged my LRAM and my RRAM, I'm just going to write this down for you. If I averaged LRAM and RRAM, I would get an average of approximately 1.1165. Okay, the actual answer is 1.0986. Okay, so as you can see, our answer is in between our two values. Okay, our average is a lot closer than either one of these, and then the actual is right there. Okay, obviously we'll learn how to find that actual one a little bit down the road. All right, any questions? All right, so like I said, we're going to stop doing all writing all that out. Okay, so from 4 to 9 is 5 units. 5 subintervals is going by ones. Okay, so we're starting at 4, we're going to 9 by ones. So the integral from 4 to 9 square root of x dx equals, our widths are all 1, and now we're going to plug in all our numbers. Okay, we're going to start with 4 and work our way to 8. Okay, we want 5 numbers. Okay, so plugging in 4, the square root of 4 is 2. The square root of 5 is the square root of 5. The square root of 6 is the square root of 6. Square root of 7 is the square root of 7. And the square root of 8 is 2 radical 2. And by the way, if you wrote the square root of 8, that's not necessarily wrong. We can't combine any of these anyway, right? That's final answer because we're multiplying 1 by that. We can't combine all those. So unless we're using a calculator, that's how we would leave our answer. I don't think I even found the decimal of that one. I didn't. So not even quite sure what that actually is. All right, so now doing RRAM. Okay, the base is still 1. And now we're starting at 5 and working our way to 9. So it's the square root of 5 plus the square root of 6 plus the square root of 7. I'm going to leave this one as the square root of 8. And then plus the square root of 9 is 3. And again, that would be our final answer. All right, how we doing so far? We good?
Yes, sir.
Go ahead.
Okay, so will there always be RRAM and LRAM? Will we be given one at a time or always
Yeah.
be given-
Typically, and on any given question, they're going to ask you to find one because they're going to ask you if it's an overestimate or an underestimate, and you'll see that here in a minute, right? I think, but typically you're not going to do both because if you did do both, then you would know which one was over and which one was under without actually knowing why it's over or under, which all goes back to that increasing, decreasing LRAM, RRAM thing. Okay. So yeah, typically you won't do both. And we're going to get to one where we're not going to do both on this very next one. All right. So now things are going to change a little bit. Okay. In all the approximations we have done thus far, our subintervals have been equal lengths, meaning they're all been 1, or they've all been a half, or they've all been 2, whatever that may be. Okay. But that's when you're given an interval and then how many subintervals. You're always going to divide it. Even if you, for some weird reason, ended up with a base of, let's say, 3/7. Okay, every single one would be 3/7 if you're given the information this way. But if you're given a table, things are going to change. Okay, if I were to actually draw this out, the distance between here and here is 3, but the distance between here and here is 4. Here it's 2, here it's 4, and here it's 5. So I can no longer do that thing where I factor out the base and then just add them all up and multiply, or like I did if I go back to this one where we just put the half out there, because this number, and I'm going to even go further back. Okay, the way we wrote this one out, where we wrote 1 times, 1 times, 1 times, this number right here is going to be different every single time when you're given a table. Okay, so the base of your rectangles will be different. Okay, it doesn't really hurt us in any way, but we do that. Okay, so the question is, estimate the integral from 2 to 20. We're going from 2 to 20 in our table, f of x dx. So they don't give us the function, and the reason why they don't give us the function is so we can't do it algebraically like we've been doing up here. Okay, and using an LRAM with 5 subintervals, right? Here's 1, 2, 3, 4, and 5. They gave you 6 points. They told you 5 subintervals. Okay, so here we go. The integral from 2 to 20, f of x dx is equal to, the first rectangle has a base of 3. From 2 to 5 is 3 units. We're doing an LRAM. So of the two numbers, the two y values we have here, we want the left one. So multiply that by 2. The height of the first rectangle is at 2, 2. And the base is going from 2 to 5. Okay. Plus, the next rectangle has a base of 4. And of these two numbers, we want the left one, 5. Okay. We're not plugging our X values into a function like we did up here, right? We plugged 4 into square root of X, 5 into square root of X, 6 into square root of X. We're not doing that because we don't have a function. We're just using a table. All right. The next rectangle is a base of 2 and using the left number times 7. Next rectangle is a base of 4 times 10. And then the last one is a base of 5 times 11. Okay, we're going to skip all the mumbo jumbo, and I'm just going to tell you this is 135. All right, so any questions where I got any of my bases or any of my y values? Okay, so now it's going to ask you, is this an underestimate or an overestimate? Okay, I'll tell you how to do that and then how we're going to write it. Okay, this is obviously key right here. It told us it's a continuous function is increasing on this entire interval. Okay, you're not going to get one increasing and decreasing at the same time. So we're increasing. I told you the other day, just draw you a line that's increasing. And we are doing LRAM. So if you're doing LRAM, you're always going to start your rectangles from the left and go to the right. So our rectangles would look like that. You don't have to draw very many of them. You just really, if you draw one and you understand it, right? But as you see, we're losing some area in here, right? We're not getting all of our area. So we're going to write, it's an underestimate. And we obviously have to explain. So here's our explanation. Okay, underestimate, f of x is increasing and using LRAM. That's all you got to say. Okay, so you got to answer the question. It's an underestimate. Is it over or under? It's under. Explain. F of x is increasing and we're using LRAM. That's this picture. You can't just draw the picture like this and they understand what you're doing. Okay, that's your notes to yourself. And then you just got to write that explanation. It's all that's needed. We don't have to write those paragraphs you guys have been giving me all year, okay? All right. I only want to get to one more of these because I got a few things I want to talk to you about. So let's just do number 8, which is going to be an RRAM one, okay? But they're all basically the same. All right, so number 8, we are estimating the integral from 2 to 12, and our table goes from 2 to 12, g of x dx using an RRAM with 4 subintervals that are suggested by the data. So we have, this is a width of 2, this is a width of 3, this is a width of 3, and this is a width of 2. Okay, so the integral 2 to 12 g of x dx. And while I'm talking about this, I hope you guys were able to go look at the answer key to the test that we took before break, and you were able to see what you did wrong or understand the problem a little better. But I do want to talk about this. There was an FRQ, and several of you, the function given was g of x, and several of you wrote like let's just say the question is, where is f prime increasing? And you would write, or where is f increasing? And you would write f prime is greater than 0. Okay. If the function given is g, you can't change its name. Okay. I know what you're talking about, and I think I just wrote it on your paper. I know what you're talking about, but someone who never has met you before, not that I have met you, but someone that doesn't even know you in Kansas City in July grading this test is going to mark it wrong because they're going to say, why is he talking about F, or why is she talking about F? We're looking at G. Okay, so you can't change the names of functions. So if you accidentally write f of x here, they're going to be like, where'd that come from? Okay, so make sure you're very meticulous about that. All right, so my first base is a 2, but we're doing an RRAM now. So of these two numbers, we want the right one this time. So 2 times 20 Okay. Plus next base is 3 times 21. Okay. At this point, you're just using these four numbers, right? 20, 21, 24, and 30. Okay. The next base is 3 times 24. And the last base is 2 times 30. And I don't have this one written out. So what is this? 40 plus 63 plus 72 plus 60. 130, 190, 235. That sound about right to everybody? I hope. I didn't have that one written down. All right, I wish
It looks right.
Okay, thank you. All right, I wish this would have been decreasing, but no difference because it's actually different than the one we did, okay? We're increasing, but we're doing an RRAM. So when I'm doing an RRAM, I start my rectangles on the right, and it's obviously an overestimation, okay? So I'm going to say overestimate f of x is increasing and using RRAM. And that's a good enough explanation. All right, you have a worksheet that's for your homework. Listen to this real carefully. This is kind of important, okay? Because I do not know what's going to exactly happen. I need you guys. It's not a big deal. It's 4 points. It's not even going to change your grade at this point. But just so I can see your work and make sure everybody's understanding this, I need you guys to turn that into me before midnight tomorrow night. Okay, it's open to, and I'm hoping it's still there. Since the semester is ending, we don't know what's going to happen with Canvas. We don't know if it's going to disappear. We're not going to be able to see it. I have to upload all the grades and into a PDF before I leave tomorrow. Blah, blah, blah. You don't need to know all that, but just try to get that in as soon as you can. We'll go over it Monday, and then I'm just going to carry that over, and then we're just going to resubmit it Monday so we can be the first grade of the next quarter. We might do all 3 of these assignments, 1, 2, and 3 again. Okay. But so don't lose your other assignments, 1 and 2 that we've already done. All right. Few other things. Tuesday is homeroom schedule. So if you don't have it, take a quick picture of that. But we will not be starting our Zoom meeting on Tuesday until 9:10. Okay. And then every other day will just be normal. Okay. But if you don't have this scheduled, that's the new schedule. We're going to homeroom first. Okay. So if you are going to remain an e-learner, you obviously don't go to homeroom. So you just show up at 9:10 on Monday. Okay. If you are coming into the building, I'm looking forward to meeting you. It's going to be nice. You guys are going to my 6th period, but you will go to homeroom first. You should be able to look up on your, I don't know if you can look on Canvas, but when you get here, they'll have people that, just like it's the first day of school, they'll have where you go for homeroom. And you'll find your teacher, you'll get your schedule from them. For those of you coming into the building, obviously make sure you have a mask and, all the protocols of that. I'm going to warn you now, because it will be confusing on Tuesday. When you go to lunch, it's not just get in line anymore. You have to just go sit down at your table, and then teachers come around and tell, they only let 6 to 8 people up in line at a time. So just so you're not the people that don't know what's going on, you have a heads up on that. Any questions for me about anything? First semester's over, and we're like around 100 days until the actual exam. The exam's on May 4th. All right, guys, have a good 4-day weekend. Again, I will see those coming into the building on Tuesday, and everybody else I'll see at Zoom on Tuesday. Have a great weekend.
Mr. Masson,
Yeah.
I had a question about the work review.
Okay, go ahead.
Okay, so when you were doing the number 8,
Uh-huh.
I was kind of confused in how you knew it was overestimate. Is it just an overestimate because you're using RM or no?
It's an overestimate because I'm using RRAM and it's increasing. Okay, so instead of memorizing, there's four ways to do it, right? LRAM is either going to be an over or an under, and LRAM and RRAM is going to be an over and under. Okay, there are 4 different ways to do it, right? So if I drew you 2 lines increasing, 2 lines decreasing, right? And we'll call this one LRAM. We'll call this one LRAM, okay? If I'm increasing, LRAM is going to be this scenario, right? And so I'm an underestimate every time. Does that make sense? Because of that
Yeah.
little area in there every time. Is that a good enough picture for you?
Yeah, it is.
Okay. If I'm doing LRAM and I'm decreasing, my picture is going to look like this. This is always the easier one to draw. And I'm going to be over, right? Over, under. If I'm doing RRAM, okay, if I'm going this way, I'm over. And then if I'm doing RRAM here, okay, I'm going like this. And I'm under, okay? I don't want you to memorize those 4 things, okay? What I want you to do is every time you get to a problem and it asks you, are you over or under, it's going to tell you if you're increasing. And if it doesn't tell you you're increasing, you can just look at the table. 17, 20, 21, 24, 30, we're increasing, right? Okay, so don't try to memorize these. Every single time when it does it, draw a line. We don't have to draw the actual function they're giving us. Just draw a line, whether it's increasing or decreasing, and then just draw these triangles and then you figure it out. But it's going to change, right? So there are 2, RRAM can be either over under, LRAM can be over under. The 2 things that determine it are increasing / decreasing, and then whether you're doing LRAM or RRAM. Okay.
All right. Thanks.
You're welcome. Anybody else got a question?
No, sir. Have a good weekend.
You too, Katya.